Thank you very much. That was not an intentional pause for applause. Please do not applause after every slide. Thank you very much. Oh my God. So, on today's agenda, we will be going over the rocketry team, the competition that they attend, their mission concept, the overview of departments that you will all get a chance to apply to later, and rocketry as a hobby. We'll be going over the rover team as well, their competition, and an overview of their departments. And finally, we'll be going over the business and marketing departments. At the end of the presentation, we'll break into groups based on on all of our technical and non-technical departments. So please save all your questions until the end. You'll get a chance to ask it directly to the lead. So without further ado, I'd like to show you guys rather than explain what we've done so far.
Nobody saw the last 2 seconds of that one. Cool. I am the team manager for the rocketry department. And basically every year we go to Launch Canada, and this is our team at the conference. You can see what our rocket used to look like. And what is Launch Canada? Launch Canada is an opportunity for us to show what we've worked on all year. It's a yearly event in Timmins where there's schools from U of T to York to ETS, and it ranges everywhere from solid to liquid rockets, and basically inspires people to push further in those departments. And it really is the best opportunity for us to learn as a team and kind of, trial and error. There's no other place we can really launch these things. Um, and on top of that, with OTMK1 was our first steps into rocketry. And with MK2 was the first high altitude flight we were able to achieve. And with MK3, which was a big leap, was doing a two-stage rocket system. On top of that, here is on this is the Klingon, or the Timmins Klingons, and they were obviously riding our rocket at some point, which was hilarious. Here's another video, and at the end of the video, you can see that we obviously hit the self-destruct button. Not on purpose. And you'll see a separation, and you'll see the second stage ignite. And obviously, you can hear the emotions that come with it, and that's right there where we're shredded apart. But it was an absolutely unbelievable experience. I think that was day 4. Um, day 5? Day 5. Well, day 4 of comp. On top of that, this year we'll be moving into doing another two-stage rocket, but we will successfully do it. On top of that, we're looking at building our own launch tower this year, and also moving to a CubeSat system for the payload. We're also talking about, also in the midst of doing a hybrid motor program, which will hopefully static fire at Launch Canada. And on top of that, we are currently printing a 3D printed nozzle for a liquid propulsion system. And with that, I will move to the chief engineer.
All right, my name is Ivan. I'm the chief engineer, ex-propulsion lead, excuse me, from last year. And I want to mention something about all of us. Most of us are engineers, applied science faculty as well. And I want to mention that we're being taught a lot of theory and not much practice. And even such trivial things as putting one pipe into another, that sounds very simple, in practice turns out to be a disaster. Last year, we purchased 2 rocket motors. You can see one of the casings, like right here. They're about this big. They produce roughly half a ton of thrust when you launch them, and they're commercially made. And what's more interesting is under the supervision of Launch Canada officials, under the aerospace engineers with 30 plus years of experience, who told us to get the lining using the ratchet strap right there. To those who don't know, ratchet strap is a mechanism that allows you to use a ratchet and lever to create 120 kilograms of force, roughly. We got it in and we got it stuck. and we were in the middle of the forest trying to figure out what to do with it. Uh, so me and Dave, okay, right there, uh, we ended up just walking in the forest, finding a trailer full of dowels and pipes, temporarily borrowing one of the dowels, and putting ice inside and pouring hot water over it to get it out. Uh, it took us what 20 hours to construct the motor, even though it usually takes 20 minutes as it's supposed to be. Uh, and what I'm saying is that only in the rocketry team and other engineering teams, you'll get hands-on experience of doing real stuff, and you will quickly discover that your beautiful CAD models, differential equations, all of that stuff doesn't always work in reality as you intended. And you can see how happy we were to discover the motors. Um, that's pretty much everything I wanted to say. And me as a chief engineer, I need to make sure that those things and those models come to life and actually work and not end up working like this. We had to drill holes in this one, by the way. This motor is disabled because there was a tiny chip on the inside upon production. $1,600 worth of metal just sitting here, not doing much. That's the price of a mistake of us as rocketeers and engineers. Thank you. And that would be next would be outreach.
All right, hello everyone. So before we get to the nitty gritty of the technical details, I want to start with outreach. So per the course, I am the outreach lead, and what we basically do is make sure that everyone here learns about what we're doing, and everyone outside learns about rocketry. So the mission goal of outreach is to inspire the next generation to fuel curiosity about the space and rocketry industry and to promote what a post-secondary STEM degree can do to their future. What does that mean? Who here, before coming to the university or even hearing that we were doing an open night, who here knew that hobby rocketry existed? All right, that is a fair amount of hands, more hands than I was expecting. But bottom line is, if you were able to look around, you can see that maybe, I want to say maybe a third of us had no idea what it was beforehand. Now think about that and then scale it across all of Durham, all of Ontario, all of Canada. Not a lot of people know this exists. So we want to get the word out there that we can do stuff like this. So what do? Well, a couple things. First off, we do internal events. So like this right here. Oh, sheesh, sorry. Outside of that, we have stuff, you may have seen us if you were here last year for open house, or if you were at Experience Day during the last March, you may have come to our, you may have come to our lab and seen us there. Outside of that, we do exterior events or external events. We have workshops. So right here you can see we are building model rockets at schools outside of the university, of course. And then we also have our conferences. You can see here we have our team who went to one of the conferences up in Brampton to, again, promote curiosity about rocketry to current like high school students, and sometimes we even go to middle school as well. So as you can see here, I also have research and development. So what does that mean? Well, currently what we're working on is rocket prototypes. So even if you feel like what may come ahead might seem a bit too, let's say, technical, in outreach, what we're working on right now is building 3D model rockets. So they're about, I'm going to put the microphone down, about this high. And what we basically do is we let these students 3D design them themselves from scratch. So we use something called Tinkercad and OpenRocket to both model with free software and simulate with free software. Afterwards, we print off their designs, if they're safe, of course, and we hope to launch them. So as you can see here on the side, we have some of the prototypes we're doing in-house, as right now what we're working on is making sure that this even works. So, of course, we have other workshops coming up as well, but all in all, if you join Outreach, we're here to make sure that people are inspired and make sure that we can inspire people in a way that no one else can. But outside of Outreach, stuff gets more technical. So if these rockets seem a bit too small for you, don't worry. Aerostructures is coming up next.
Thank you, everyone. So my name's Adam. I'm this year's new aerostructures lead. So yeah, let's just get on with it. So a rocket only flies as far as the structure allows. That's what I'd like to say. Key thing about aerostructures. So you might be asking, what is aerostructures? Okay, we are essentially everything you see on the outside of the rocket, right? With the airframe and the rocket design itself. So we primarily do the CAD design of the rocket, from the nose cone, the body tube, the fins, even some stuff on the inside like the bulkheads. That's all our stuff. But we're not only structures, right? We're also aerodynamics. So we also do lots of calculations and simulations using different softwares like ANSYS. So what we're trying to do is get an idea of what our rocket will do before we actually launch it. Um, and yeah, at the end of the year, when we fully designed and like simulated our rocket, we're going to be constructing the entire thing. We have to figure out what materials we actually want to use, right? We machine all the parts, and then we all come together. Uh, and it's pretty fun, honestly, at the end of the summer, or start of the summer, where everyone's just building a rocket, and yeah, hopefully we can build something like this. So you might be asking why aerostructures is so important. Well, we're basically the foundation of the entire rocket because we are like the outside of the rocket, right? So we have to account for every small little detail because if we mess up even the smallest thing, it can throw the entire rocket off course, right? Like if all the other departments, like you'll see coming up, we got avionics, software, payload. If these guys do their job perfectly, but we mess up, it can still be like a doom for the whole rocket. So we have to be, very responsible and yeah, like with our designs and whatnot, we have to be very careful. Like I said, everything's got to be simulated before we actually construct the rocket because gotta get an idea what it does, right? So looking at past years, rocket that we built, OT Mark III, we got what's left of it over here, but it was still a great rocket because it was our first attempt at a two-stage. And it was trying to achieve great heights of 60,000 feet, which is 3 times more than what we did last year with OT Mark II, which was only 20,000 feet. And we did other great things, like we tested newer materials, like carbon fiber for the fins. I don't think it's on there, but we did that. Only issue we really had was with the sustainer. As you probably saw in the video, after it ignited, it did like some weird stuff. But that is what we're trying to fix this year. We're trying to do basically a refinement of what we are trying to do last year. So another two-stage rocket. And just figure out all the kinks, all the issues that we had last year, and really perfect this two-stage for this upcoming year. And then going from there, we can do even crazier and better things. Another thing we're trying to do is a custom launch tower project. So our rocket's gonna launch from like a certain base, and making it ourselves, we're really like allowing us to fine tune and have the desired specifications for our launch. So the rocket launches exactly how we want, which is the main goal. Um, but yeah, overall, if you love CAD, if you love simulations, and even building the rocket at the end of the year, then I think aerostructures is definitely for you. But if not, we have other departments as well. So it's gonna call Payload up here now.
Hello. All right. My name's Andrew. I'm the payload department lead. So what is the payload of the rocket? Essentially, this is to answer the question, what are we launching this rocket for? Of course, we're trying to win a competition, but within the context of the competition, we need some kind of justification for why we would launch a rocket in the first place. And the answer to that is we're trying to conduct some kind of either scientific experiment or technology demo that can only be done at high altitude. So just to give an example, what we did this past year was we put spectrometer and a dosimeter in the payload bay to measure radiation at a high altitude and compare that to radiation close to the ground to collect data on that. And we also had an additional experiment where we were using strain gauges to measure vibrations that the rocket experienced during flight, which would be useful data for aerostructures later on. And in addition, we also had some onboard cameras. So what's the plan for this upcoming year? We're going to make our payload bay follow the CubeSat layout, which is a standardized small satellite layout. The goal with this is to be able to iterate on the design of our payload in future years because we standardize the base, so we're not redesigning that every time. We're going to measure the forces and stress experienced by this CubeSat during flight. And then we're also, as an experiment, going to try and redo some radiation measurements like we did last year. And if we're able to, also have onboard cameras as well. So if any of this sounds interesting to you, you might like the payload department. It's worth mentioning there's a little bit of something for everyone on here because the payload's its own whole system. If you're in mechanical, electrical, even nuclear engineering, there'll be a project to work on. So with that, we have avionics.
Perfect. Thank you very much, Andrew. So, good evening, everyone. My name is Jasraj,
And my name is Connor Jennings.
and we are going to be your avionics lead for this year. So, avionics. What is avionics? Basically, we are the brains and nervous system of the rocket itself. All the wiring is done by us. So, meaning if anything bad happens with the wiring, the rocket is either not going to fire, is going to go something wrong in midair, or we won't be able to track it. So, what do? Basically, we design our own custom PCBs, which are called SRADs, which are student researched and developed boards. Anyways, basically, all we do is design custom PCBs. So if you're in electrical, mechatronics, this is kind of what you want to be doing. We do our own wiring, custom soldering, and also we test our own PCBs as well. And also what we do is also make sure we practice all of our pyros, making sure that it doesn't fire accidentally in someone else's hands, and making sure that nothing bad goes on when we're on the launch pad. Also, we work with all different departments such as aerostructures, payloads to make sure that their systems are working compliant with us, and also software to make sure that all of our COTS, which are commercial off-the-shelf board, are able to be working properly.
So this is a quick summary of what happened during Launch Canada 2025. This is our main avionics bay that controlled both the staging, the ignition of the sustainer's motor, as well as the dual deployment parachute system, which we'll let Recovery talk about later. For the rocket, this is our basic wiring diagram. This is our ground station with an antenna for tracking. And then this is the path we followed to recover the rocket, which came from said ground station. So, like Jasraj said, there's student research and design, and there's also commercial off the shelf. Commercial off the shelf is used because regulations, and we are using these different systems here as our off the shelf components to control the parachutes. So we're using the Blue Ravens, the Featherweights as trackers, the Speedy Bee to potentially control some air brakes, and the RC3 Plus. So these are some of our student research and design projects. So we're modifying the rocket beacon, and then we're also going to be creating air brakes, which I'll let Jasraj talk about.
Perfect. So basically, our SRAD for air brakes is basically creating a system to create drag. As many of you or who are engineers understand that drag basically allows someone to slow down. There's things like parasitical or skin drag. Basically, we want to make efficient drag, which slows down the rocket because, for example, whenever the rocket tilts, it will create horizontal velocity, meaning that we want it going up, it will go sideways. And sometimes we don't want our rocket going beyond Narnia. So that's what the air brake system does. Basically, it slows down the rocket to allow us to reach either optimal apogee and make sure it doesn't go really, really far.
And next, we'll pass the ball on to Recovery.
All right, so moving on to recovery, I mean, I'll give a little bit of an idea of what recovery is like right here. So this is actually a diagram of our recovery system from last year. And as you can see, we got a lot of parachutes, we got some blankets, we got some cords, and we got some links. Most of our recovery system this year will be quite similar. However, there will be some key differences that I may go over. So what do we do? Well, I mean, everything that goes up must come down, and unless gravity reverses itself at 60,000 feet, that will continue to be true. We are the people that make sure the rocket goes from up there to down here without killing somebody, because that isn't very good. So We build parachutes. Well, actually, that's what we're starting to do this year, and this is a little example of a homemade parachute from somebody else. But we actually have a couple examples here that you can look into after the presentation. We buy linkages, shock cords, almost everything you can think of that can go into a recovery system. We also, as part of recovery, we have to go get the rocket once it's back on the ground, which will involve going out into the woods. As you can see right here, this is actually one of the pieces of the rocket we recovered, and we have that bay right over here if you want to go look at it. Hold that up, right? Nice and high for everyone to look at it. That is that piece in the picture right there, at least part of it. And we also have to size out the parachutes once we know all the masses of the rocket, and that involves a lot of Excel calculations. And this is honestly, now that we're going into making our own parachutes, we're gonna have to start testing them. So we're gonna have to figure out how strong they are, how much drag they have, and there's gonna be a lot of prototyping involved in that. We will also be required to stress test other components because honestly, we don't exactly know how strong a lot of the components tend to be because we're not using them the way that the manufacturers intend, especially the U-bolts. And we'll also have to do a lot of ground testing because we have to make sure that since we're moving to a pure CO2 ejection system next year, we have to make sure that the CO2 reacts the same way as the black powder for the purposes of our cords, since we're planning on using nylon shock cords instead of Kevlar this year. And in that bottom picture right over here, here's an example of the CO2 ejection system we use. We actually saw, if you were looking at the avionics slide, these little things are still on the avionics bay. So we'll have to pick up another set of those and we'll start testing. So if you really like, if you like prototyping, you like testing, honestly, recovery might be a good department for you. If you love being outside, you like sewing, that's another plus. So we'll be moving on to propulsion. So if you'd like to come up.
All right. Hello. My name is Michael Bonarenko. I'm one of the propulsion co-leads, and I'm with.
Hello, my name is Mahmoud. I'm the other co-lead for the propulsion department.
All right. So what do we do? This year we're doing a few things. So the first thing is we have to make sure that the two-stage rocket we launch with solid fuel actually launches. And the second thing is, of course, building a small hybrid rocket to actually static fire test at Launch Canada. So this means a lot of research, a lot of development, a lot of testing, because the hybrid rocket is going to be having a fuel grain that's approximately this size. It's going to be big, and we don't want to blow ourselves up.
For designing and building this hybrid rocket, we're gonna have to do a bunch of simulations. And we like to use OpenFOAM, type of computational fluid dynamics simulator. And it will be hard, and we will be using more of the advanced settings like combustion and compressible flow. But if you do want to learn it for your own sake or for fun or for your career, this would be the department to join. We will probably use it more and more in a more sophisticated way than any other department. That I can guarantee you.
Exactly. Now, why do we do propulsion? We love it. We love launching things. We love burning things. A little bit of pyrotechnics. And yeah. All right. So what's the kind of plan for propulsion? There's 4 big stages. So before we build the big one, we have to make a few small test cases to make sure our simulations actually work, to make sure we have a little bit of data on the different fuel injection methods, ignition methods. So that's going to be until October. Then by January, we'd have to design out the actual full scale rocket, hybrid static fire test, as well as build the launch, the test firing stand and all that. And then between February and April, we're actually going to be constructing it because we want to test it at least once before LC, just to make sure nothing goes wrong.
Now, why should you join propulsion over any of these other departments? The way I see it is propulsion will sharpen you. It will make you better. And the evidence in that is our new chief engineer was the former propulsion that actually worked under this guy. And he would hammer me all day long. If you want to refine your own skills and actually get much better and not just put this on your resume for the sake of it, really understand the mechanics you're working with and learning in class, propulsion's the place to go. If you want to do something not because it's easy, but because it's hard, this is where it's at.
Let's see. Software is next.
Hi, I'm Chris. I'm the software lead of the department. Software, I mean, every design team, every engineering firm, every place you're going to work is going to require some sort of software team. And so the department acts more as a jack of all trades for a variety of different work across every single department you'll ever work with. As you can see here, this is a list of a variety of projects that software kind of covers. We cover everything from UI design for tracking, altimeter programming. A big thing about rockets is controlling when you're separated, controlling when your parachutes deploy. This stuff isn't automatic. It doesn't magically happen. You need to simulate it. You need to time it properly based on what you're getting. And of course, you'll do rocket simulations. We're going to be doing CFD simulations to figure out coefficients of drag for your aerodynamics, working with avionics for programming, working with payload for programming, and a variety more. Do we have any software engineers today? I don't suppose computer science students too. Okay, we got a couple. Yeah, I like to see it. Normally, I assume not a lot because mostly they're in their rooms, but a big project with software and something I enjoy personally overseeing is the ground station. If you want to open that up, Michael. You close the shell. Oh my god, this guy. Ground station is an all-in-one functional computer. The ground station's an all-in-one functional computer. As site can get messy, and we want to bring as much equipment with us as possible. Last year and in previous years, the ground station. I swear to God, you rat. The last year, the ground station involves a lot of flight tracking. We need to be able to understand data in real time that we're getting from the rocket. If without us, we really wouldn't exactly know where we would recover this thing and know exactly where it's going to be. And as part of the ground station projects, if you're interested in that, it's a combination of both software development, front end and back end for these applications, control systems, as well as actually hardware design a computer that can fit in a box and be well ventilated and incorporate seamlessly, especially as we go into using controllers of the design, which is the future of ground station. Before, we've always been solid rockets. We are delving into very complex simulations for liquids, hybrids, all sorts of stuff, and it's not as easy as just igniting it. You need to know exactly where your pressure tank fuels are. You need to know exactly where your heat ratios are. You need to know how hot when do I need to pour coolant over things? When am I allowed to fly? It gets very technical, very physics-based, very complex, and the ground station this year will be redesigned to be able to work as a test stand for the motors we're experimenting with. It really isn't a small deal. These motors that we're building very easily can kill tens of people on site. Lots of safety procedures go involved. If I want for a sec to invite our safety lead over here.
All right, good evening, everyone. My name is Xavier Goupy. You may also refer to me as Xavier. I'm the Chief Safety Officer for this year at Ontario Tech Space and Rocketry. If some of you remember the flowchart at the beginning of the presentation, you can see we're a very ambitious team, and that's a good thing, but with ambition comes risk, and with risk comes safety. Safety is often overlooked. It is a very serious position, and we must ensure that all of the control from the design to the rollout to the recovery is safe. And there is no way around it. And now I will invite the business lead. Sorry.
I stole the slide.
You still have a slide? Never mind.
Sorry about that. Little. Of course, we do have other work other than the ground station for our sole computer science student, and maybe if he has friends. software incorporates a lot. We need a team that helps develop a website, manages and maintains the general structure, storage management, whether that's cloud storage systems or some sort of local hardware that we can run. As well as research projects. I do stuff with parachute simulations. And if you're on Avionics or Payload, I may very well likely be overseeing some of the stuff you're doing with your embedded programming of SRAD components, as well as programming general payload, anything really. You're always free to come to ask me questions about anything like that. And you're always free to pitch ideas because software isn't really something that's constrained by funding. We are open to research in the aerospace field and innovating in more ways. And now to business.
Rover. Okay. I'm sorry.
To Rover! To Rover! Okay, so I'm Eric. I'm the team manager of Rover. It has been over 5 years since the school has attempted to do a rover. Last time they did it, it was the robotics team. This time, it is going to be the space and rocketry team. Okay, so our purpose, it's pretty much just to develop things. Like the rocket's going pretty well, but it's pretty specialized. So it is to develop the team farther, look into different things, specifically rovers, which will tie in well with our CubeSats that are coming up and other things like that. I want it to be a hub where everyone comes together to actually build something great. So the competition that we are looking at doing is the Canadian International Rover Challenge. It takes place in Alberta, out in the Badlands. Pretty good soil for mimicking Mars. As far as how we are organized, we have our mechanical department, which is basically taking care of chassis, suspension, steering, drivetrain, all of that good fun stuff. We also have an electrical department, which will take care of the batteries, the power, running solar, so we can actually get through the 3-4 hour long tasks. And then we also have our navigation, guidance, and controls. So you software people, that is for you. We are looking at doing artificial intelligence, computer vision, and basically having the robot be able to move on its own. And as far as collaborating with Rocketry, their business and media departments, along with outreach, will be helping us out so that we can focus on building rovers. So our deliverables for this competition, which is actually a rather large rover, it is supposed to be 50 kilograms. So 2 people can barely carry this thing. It will be 1.2 meters long by 0.8 meters. Ideally, it will fit through a man door under its own power. Our longest task is 3 hours, and some of the tasks take place during the day, some at night, so it will have infrared. It will be able to have computer vision in infrared. And otherwise, it will actually end up with a rather large arm with the purpose of manipulating cabinet doors to mimic like a space shuttle crash site, as well as actually dragging a human body, or at least a simulation of a human body. We may actually have to do tests with real people. So it'd be looking for drivers, and I would end up being the one getting dragged, because I'm not going to subject any of my team to that kind of peril. Unless they volunteer. If we have volunteers, you can get dragged by the rover. Otherwise, it'll be reading Aruco tags and some other computer vision stuff to identify things. And so we have come up with a few designs. We're That one is a nice center pivot where it has steering controlled in the middle. Uh, the yaw gets dampened, and then the roll is actually free rolling, so it can pivot completely on its side. Otherwise, we have this one, which is a double rocker bogie, which if you want to hold up my little demo bot, that is a single rocker bogie. I believe the model we have chosen is to go with that classic design. But we do have the CAD of, at least a rough CAD of the arm we're going for. It will have carbon fiber tubes to keep it nice and light so we can keep the weight as low as possible. And now I will hand it off to business and marketing.
I said,
Okay. Let me go to my slide. All right. My name is Arnab, and I am the media lead for Rocketry and Rover. So, before I get started, did you know OTSR is the best rocketry club in the world? Yeah, that's exactly what we try to prove with our department. We don't know, but we strive to be, definitely. Um, in today's day and age, what I feel is one thing that matters the most that how you present yourself out there through website, through social media, through any other means. All these cool departments you just saw, they do great things, they achieve great heights every year, but we need to present them the best way possible in front of all of you guys to make them look better and to convey the ideas that they're trying to prove. And that's our job. Um, we we do everything almost for all sorts of promotion. We make beautiful merchandise that a lot of our teammates are wearing today. We make patches, we make stickers, we make posters, and you can see our beautiful Instagram handle. Um, what what we strive to do here is to get you guys involved, even being a member, not being a member, to know us better. We're we're all beautiful human beings who try to make a beautiful club, and I think it's a great community to be a part of, and I definitely vouch for it. But I and currently we definitely need some of you guys to be to take up this challenge and make us look better in front of this university, in front of Canada, in front wherever we're challenging, wherever we're presenting in Launch Canada and in the Rover Challenge. So yes, this brings me to yes, we need graphic designers. We need media people. We need people who can do this job better and make us look better in front of all the universities and other people. Okay, and you recently, I think a lot of you guys would have seen a bunch of reels floating around on Instagram. Um, and that might have even brought some of you guys to this room. So my point here being is if it's presented right, it can make a great impact. And we have our former president who did a very good job. Oh, not have never mind. But is the volume up? Do you know? Never mind. I'll try my best. Never mind. Because I can, yeah. Because I cannot see from here. Give me 1 second. All right. right, I will give this to relations and funding, which
Hello, everybody. My name is Dave. I am the Relations and Funding Lead for both Rocketry and Rover. So, in terms of money, we have no money. It's very expensive to build these things, both the rocket and the rover. And you can imagine how much more expensive it is when we don't get it back. So it is our job to make sure that everything that they need goes smoothly. They worry about the technical, and we just give them the money, and we go reach out to sponsors. So relations and funding is split between three different departments. The name is a bit misleading. We mainly operate as the finance, sponsorship, and relations. So finance mainly handles spreadsheets. We do meetings with the faculty to discuss the bill of materials for the rocket, and we go over like extra expenditures that we need to do, and we keep track of the income and outcome for everything that we purchase. We also reimburse everybody so that no one's in the hole. Um, and an actual aside note for the finance is since a lot of the work is spreadsheet based, we actually had the opportunity to do something a bit more interesting this year. So we had a small group compete in the Tech Dev Challenge at Launch Canada. It's a whole separate challenge about a whole different thing, but one of the components of the challenge is a business case analysis, where I'm sure if some of you are engineers who were in first year, you will remember doing stuff like a cash flow and profit graph over like 4 quarters of a year. So we actually got to build an analysis and those graphs based on real world data to present to judges who were not only like leads of companies, but also ex-engineers to be able to promote this product to them. So it was a nice one-off event. Maybe we'll redo it in the future, but it's a great way to demonstrate those skills that you learned. Sponsorship, they are the most important. The faculty gives us enough. Unfortunately, we still need more. So we need in-kind and monetary donations. So this can range from cold emailing NVIDIA, cold emailing Google, or asking Osmos to see if they can spot us lunch or dinner. And examples of in-kind donations are Rotor Village, who gave us the run camera for Payload. That was in the nose cone. It recorded a beautiful shot of Timmins before it was forever lost. We have Ripstop by the Roll. They helped sponsor us a large amount of fabric for Recovery's special homemade parachutes job. So that made it a lot cheaper. Altium and Ansys are very advanced CFD simulations. And each software alone costs 8K a piece. So being able to get those sponsored for us really saves us a lot of time and saves Aerostructures a bunch of headache. And the relations team mostly shows on different than Luke's outreach team. We do not promote engineering, but more the team and rocketry interests in general. So I know a lot of you saw our Instagram posts, a lot of you saw our posters, but you'd be surprised how many people at this school didn't. A large majority of the students that we asked, we did a little survey, not many did. So their job is to go around and create events in the Shaw events with the OTSU in collaboration. We have one of our members actually works in university, works with the school's media department, so we can get showcased by them in order to promote our engagement within the school. Outside of that, we have our engagement with the Durham region. So that is working with Luke to promote ourselves to local high schools. Luke has his own little side project there with a raffle from one of the funds. It's like we work together on that. So it's just getting us known around the area for what we do to hopefully maybe get some more sponsorships. And outside of that is the big picture, the Greater Toronto area is we want ourselves to be known and associated with the top levels of the rocketry teams. Since we have U of T so close, we want to be up there next to them when they talk about rockets in Toronto. And in terms of internal events, if you make it on the team, then you get to go to these very special events. You get to go to a barbecue. You get to go to the general meeting where you get to know what's going on. And maybe you even get to play dodgeball. We'll see. Maybe even the ice rink. Who knows? If we can get that booked, then you get to go skating. Anyways, that is all. Now on to Logan, our president, for the final address.
All right, so if that wasn't enough to convince you to join us, then I really don't know what will. The recruitment process is super easy. We'll throw up 2 QR codes up in a second where you can scan and you will get access to the application form where you will submit your resume, fill out some questions, and if you're selected for an interview and all goes well in the interview, then you will be selected to join the team. Pretty simple, right? If you do miss the QR code or you lose it somehow, it will also be available on our Instagram link tree, on our website in the Join Us section, or it'll be on our LinkedIn as well. Now, if you were feeling a little overwhelmed by the amount of technical knowledge that my leads have, I want you to understand and know that we're not looking for people who know everything. This team is for people to learn. What we're really looking for is for passionate individuals who have a good work ethic. That's all that matters to us. So please do not be intimidated if you didn't know what was going on, or if you did, please apply because we need smart people. Now, one last thing is rocketry as a hobby. So rocketry, like this rocket right here, is not just for design teams. People can build stuff like this. People can build rockets even bigger than this, completely legally. It is called high-powered rocketry certification. Now, it is separate from the design teams, but we are opening up a club that will help everyone get their certifications. It's designed to make rocketry certification as accessible as possible. And if you are not selected for an interview, or if you're not selected to join the team, you can still join the rocketry certification club, and you can prove us wrong, prove that we made a mistake. Okay, that's everything from me. Here are the QR codes. You may all take your phones out, scan the QR code. This is for the rover team. And then it has yet to be updated. You guys are the first. This QR code is exclusive. And this is for the rocketry team. All right. Now, for the round of questions. I think what we're going to do is we're going to split up the leads. Hopefully this room is big enough and not too loud, but we'll have aerostructures in the back corner. We'll have avionics a little lower, and you guys can all ask the team leads questions. Yeah. So thinking, where's Adam? Yeah. I changed my mind. We're going to the atrium.
Kick everyone out. We're going to the atrium. Just find one.
Oh, you just placards people want to take. A bunch of placards that people want to take before you are.
We will also be giving out keychains on the way out as well. Not keychains, little dingamabobs. Yeah. And posters. Please grab them on the way out.